Okay, so last week and a little bit before that, actually, we looked at solving systems of equations. Those equations just had an x and a y variable. Now we're going to look at equations that have x, y, and z. So we're going to solve systems. Yeah. Okay, so we're going to look at the steps that we're going to take before we work an example. So the first step is to eliminate a variable. So we're going to use the elimination method, which you guys learned already, to eliminate any variable from any two of the original equations. So that's going to eliminate one variable, which means you're going to end up with an equation in two variables. So once you eliminate a variable, you'll only have two left because there started with 3, we eliminated 1, then there's 2 left. Then what you have to do is eliminate the same variable from any other two equations. So you're going to choose a different combination of equations to eliminate the same variable again. And then you'll have another equation that only has 2 variables. So we start with 3 equations that all have x, y, and z. We're going to choose 2 of those equations to eliminate the x variable. Then you're going to choose 2 other equations out of those 3 to eliminate the x variable again, so that then you'll have 2 equations that just have y and z, or just have x and z, or just have x and y, whichever 2 left that are not the ones that you eliminated. Then what you're going to do is eliminate a different variable and solve. So we'll use the elimination method again to eliminate a second variable. Number 4, find a second value. So after you find one value, we're going to substitute that back in to find a second value. And then we're going to find the third value by substituting both of the other 2 values in. All right, let's work an example. Okay, so here's our 3 equations within our system of equations. We need to eliminate a variable. Which variable do you guys want to try? Z?
Sure.
Okay.
Should you do that smallest one or the biggest?
There's Z.
Why? In your preference, would you do the biggest one or the smallest?
Yeah, I'm looking for what's going to be the easiest for me to eliminate.
Z.
Z would be easy. I think X could be easy. I think really the only one that wouldn't be easy is Y.
So let's do Z. We've already decided.
Okay.
So let's do one.
Z it is. So looking at the first 2 equations, how could we eliminate the Z variable?
Get an opposite.
So we have a positive 1Z and a negative 3Z. Multiply the first equation by 3. That will give you a positive 3Z that will then cancel out with this negative 3Z. So if 3 times 4x is 12x, I would write it, go ahead and write it below the second equation so that it's already there. Then we got 3 times 8y, which is 24y. 3 times z is 3z. And 3 times 2 is 6.
So the next thing has to be positive.
Well, these, yeah, the negative 3 and the positive 3 are going to cancel.
Oh, you're right.
Wait, what do we do with that?
The x plus 12x is 13x. 7y plus 24y is 31y. Equals negative 14 plus 6 is negative 8. So that was the first step. Second step, eliminate the same variable from any other two equations. So we eliminated the z, which means we need to eliminate the z again, but we can't choose the first and second equations. We can choose first and third or second and third. Okay. So if we choose the first and third, in order to get the z to eliminate, what do we need to do? Okay. -2. So if I'm multiplying by -2, we've got negative 8x, which again, I'm going to go ahead and write this below the third one. Then we've got negative 16y, negative 2z equals -4. So multiplied it by -2 to get this equation. Now when we add 2x plus -8 is -6x. -3 plus -16 is -19. Y. The 2z, the -2z cancel. 3 plus -4 is -1.
Now we have to line other people.
So now is where it gets a little bit more complicated.
Yay.
So now we have two equations that just have x and y. So we need to use those two equations to eliminate either the x or the y. Neither one of those are going to be all that easy, but I would choose the variable that has the smaller coefficients, x. This y has a 31 coefficient and this one has 19. That would be very ugly if we tried to find the least common multiple. Least common multiple of 13 and 6 is probably going to be whatever 13 times 6 is. So we're going to end up multiplying this equation by 6 and this equation by 13. Then that's going to give us the same variable or the same coefficient on the x variables. They're already opposite signs, so we don't have to worry about that. One's already positive, one's already negative. Okay, let's do this. 13 times 6, 78x. 31 times 6, 186y. -8 times 6 is -48. -6 times 13 is -78. -19 times 13 is -247. And -1 times 13 is -13. So now the 78x and the -78x cancel. And we've got 186 plus -247. That should be 61, sorry, -61. -48 plus -13 is also -61. Now we can solve for y by dividing both sides by -61. Y equals 1. Yeah. We have to find X and Z also, but this is the easy part.
I said we did the very
Wait,
last question.
what?
The very last question.
Wait. You have to find X, Y.
Mhm. So we found Y. Y is 1. So now it is good to know. So now we go back to one of these two equations that just has X and Y before we multiplied it by something, because that's going to be easier.
The right one.
This one?
Yeah.
Okay. So we've got negative 6x minus 19. Instead of y, we're plugging in 1 equals negative 1. So I used this equation, but instead of y, I'm plugging in what y is equal to, which is 1. So now we can solve for x. Add 19 to both sides, we get negative 6x equals 18. Divide both sides by negative 6. We get x equals negative 3.
Yay.
Now we're going to go all the way back to the very original equations. We're going to choose one of those equations to plug in our y and x values. The first one, okay? So instead of x, we're plugging in negative 3. Instead of y, we're plugging in 1. And we're going to solve for z. So we have negative 12 plus 8 plus z equals 2. Negative 12 plus 8 is negative 4. Add 4 to both sides. Z equals 6. No, I want you to write your solution as an ordered triple. Instead of an ordered pair, it's X, Y, Z. So we've got negative 3, 1, 6 is our answer. No, you can. It's just a 3D. It's not two-dimensional anymore. The Z makes it 3D. X and Y, and then your Z. Yeah.
Why would you-
Wait.
Wait.
I mean, X, Y, and Z.
Hold on.
In a way, it makes
You will not have to plot these on a graph in this class.
What?
The back page has example 2.
Oh, the last one. I'm getting so good in my signature. What?
Okay, let's look at this first equation. X plus Y plus Z equals 2. How could that be possible?
Negative.
Negatives or fractions?
I don't like where this is going.
So we should expect at least one or more either negative answers or possibly fractions. So just be aware of
Possible fractions.
Alright, so
Okay.
let's start with the first one.
that. First step, we want to eliminate one variable.
Let's do A. Let's do A.
Okay, eliminate X.
No, eliminate Y because there's already a negative and a positive. You don't have to do it.
and literally you can X, Y, or Z. They're both have. You know,
They're all gonna be really easy.
Just do Y.
I heard X first.
Yep.
So which two equations then? First and third. Okay, I'm gonna rewrite the third equation. So I moved the third equation over here so that I can add it to the first one. Wait, we didn't choose your variable. Let's do it. Okay, so when we add these, x plus negative x cancel, y plus 2y is 3y, z plus negative z cancel, 2 plus 1 equals 3.
Oh my God, why is one?
Wait, so why?
Oh my gosh, why is definitely on
Y equals 1.
very bones.
Oh, okay, okay. Wait, so we're done with that one?
Well, we still have to find another variable. So
Going to the second equation, plug y.
We are good.
You could. Hey, why don't you guys take a look at what's happening now on your paper? What would you guys like to do from here? What do you
Go to the
think?
next equation and plug the one into the one.
Okay, that will then give us an equation that has x and z. Then what would we do? All of the things that we could do from here would be easy.
Eliminate X from that one.
Let's go.
Here's what I would do. I would take the third equation and write it here so that the x will cancel again.
Already plugged in the one.
No, not yet.
All right, now. Ready to go?
So now the x's cancel. Negative y plus 2y is just y. 2z minus z is just z. And 2 plus 1 is 3.
Now do we add the one?
Students, please excuse the announcement. At the end of this announcement, we will have our mandatory hire of October.
Never start having a phone say right this second or I'll.
Z equals 3. Now we plug Y in, right?
No, it doesn't.
We plug Y in.
Okay, so now we have an equation that just has y and z. We already know what y is, so let's plug it in. Y is 1.
Oh, it is. I didn't
So
think that. I didn't-
So now solve for z by subtracting 1 from both sides.
I divided it.
3 minus 1 equals 2. That's why I put a line through my z's.
Wait, so now we can put it in the thing and we can solve.
So now that we have 2 values, we can go back to the original equations to be able to get
Do
x.
the first one.
First one,
Wait to
x,
the last one.
that's okay. X plus y is 1, plus z is 2, equals 2. It will.
With the negative one.
Just
wait,
add it.
negative-
-3.
Subtract 3 from both sides.
Second one.
X equals -1.
That's what I said. at the
Okay, so there's
beginning.
no particular order to get to solving seven.
And you put
You
it
just have to get all of
Put
them.
it in X, Y, Z, right?
Yes. So here's our answer. X is -1, y is 1, 2, z is 2.
We're done. Yay.